In this business of rocks in the sky, it's like mud wrestling. And I don't want to get dirty by mud wrestling with some of these guys. And we calculated that outside the solar system, it was moving at 60 kilometers per second. I just cannot understand that. Many of these people, those that are making negative comments, many of them that didn't write a single scientific paper over the past decade, not a single one. It's just like commentators looking at a soccer match and telling the players how to pass the ball. Who gave them that authority? And I call that the stone age of science, when everything in the sky must be stones. If you tell yourself that you will not find anything, you will never search and you will never find anything.
Thank you for being our guest today. Your latest expedition, I find it very fascinating. And one could really say that you and your team found the needle in the hay, so to speak. Well, not a needle, but a handful of tiny spherules. You think that these spherules could be the remains from an interstellar visitor that crashed and landed on planet Earth? Please, yes. If you want to tell us more about it, please.
Well, thanks for having me. The story starts almost a decade ago when the US government satellites detected a fireball from an object that collided with Earth, roughly half a meter in size. It released a few percent of the Hiroshima atomic bomb energy in that explosion. And what was special about this object was it was moving very fast. In fact, it was going behind the Earth as it orbits the sun, and came at 45 kilometers per second speed relative to Earth. If it were to collide with Earth head-on, it would have moved at 90 kilometers per second relative to Earth. And what's important is that it was moving faster than the escape speed from the sun, meaning that it must have arrived from outside the solar system. It cannot be bound by gravity to the sun. And we calculated that outside the solar system, it was moving at 60 kilometers per second. And that's faster than 95% of all stars near the sun. Moreover, it only exploded in the lower atmosphere of the Earth, where the stress exerted on it was larger than on all previous meteors that were cataloged by NASA over the past decade, 272 of them. So it meant that it had material strength that is even tougher than iron meteorites, which make up 5% of the meteorites. Very unusual in material strength and speed, which suggested to me that it could be a Voyager-like meteor. Imagine our own spacecraft Voyager leaving the solar system and colliding with another planet like the Earth far away. It would appear as a meteor with unusual strength because it's made of stainless steel, and also unusual speed because it was propelled artificially. And so to find this out, we went to the Pacific Ocean, the meteor site that was defined within 11 kilometers error box. And by the way, the US Space Command confirmed that this object was interstellar in a letter that was sent to NASA in March 2022, just a year and a half ago, just to confirm the finding that the discovery of this object as interstellar by myself and my student, Amir Siraj. So our paper was published, and then I started to plan an expedition to retrieve any fragments from this meteor. And we went there with a ship that was fittingly called the Silver Star, and we built a sled with magnets on both sides to collect those molten droplets from the surface of the object when it experienced the immense heat from the fireball that surrounded it as a result of friction on air. We found them. We found 700 spherules, brought them back to Harvard University and analyzed them with the best mass spectrometer in the world. First of all, the spherules are concentrated near the meteor path. There was an excess of spherules. In the meteor site, we found twice as many spherules as in the background. So that meant the meteor added more. But in those regions where it added more, we found a special type of spherules with unusual composition that had an enhancement in the abundance of some elements like beryllium, lanthanum, uranium, and many other elements between lanthanum and uranium that are hundreds of times more than in the standard abundance pattern of the solar system. So the solar system was made out of a cloud of gas that was enriched by an exploding star, a supernova nearby. It has a uniform distribution of heavy elements and isotopes that were dictated by this exploding star. And what we found is that we have hundreds of times more concentration of some elements in those spherules found along the meteor path. And because it's beryllium, lanthanum, and uranium, we call it BeLaU as an abbreviation of those elements. Beryllium is interesting because it could be a flag of an interstellar trip because it's made out of cosmic rays breaking heavier nuclei. It's called spallation. And so if you have a journey through interstellar space, the object is likely to go through much more exposure to cosmic rays and therefore have an enhancement in beryllium. Lanthanum and uranium is a puzzle. How do you get those to be so enhanced? One possibility for a natural origin is if this object came from a magma ocean, meaning an ocean, basically a planet that had rocks that were molten. You know, the Earth started this way because it was bombarded early on by very heavy objects that collided with it. In fact, one of those objects created the moon when it collided with Earth, and the moon also started molten. So it was also a magma ocean, and Mars was the same around the same time. The thing is, we found that the composition cannot be from Earth, the moon, or Mars, or any asteroids within the solar system. It must be from outside, but it could have originated in the magma ocean where if there is an iron core, some elements are attracted to the iron and they sink to the center, whereas whatever is left behind is the type of elements I'm talking about that were enhanced in this object, like lanthanum, uranium, and in between them. But the problem, the challenge with this explanation is that you need 10 to the power 23 of such a population of objects per star, 10 to the 23 of them per star, each of them weighing roughly a ton or 500 kilograms, like this object, so that one of them would collide with Earth every decade. This interstellar object collided over 1 decade. It's the only one that we are sure of. So once per decade requires 10 to the power 23 per star in the Milky Way, which is a large number. If you multiply 10 to the power 23 times the mass of 500 kilograms, you get roughly the mass of the Earth. So you need the whole Earth worth of magma ocean to be broken into tiny pieces, each of them 500 kilograms, around every star. Which sounds challenging to me in an astrophysical context, but maybe it happens. And then if it's not natural, then of course it could be artificial, manufactured technologically, because lanthanum, for example, or some of the other elements that are enhanced, they are used for semiconductors, you know, as a substrate. And uranium, we know, is used in fission reactors to produce energy. Maybe a technological device would have an enhancement in those elements. To find out for sure if it's technology or natural origin, we plan to look for a bigger piece of the object in a future expedition. And obviously, if you see a piece of a rock, it's very different from a piece of a technological gadget, which could have buttons on it. The question is whether to press a button or not, if you find it.
Of course, it is so interesting, and it was one of my next questions. I was about to ask if you were looking for the main mass of this object also, because it must be somewhere. So
yeah, I should say that in the fireball, what we saw is a few percent of the Hiroshima atomic bomb energy deposited into 500 kilograms of material. But we don't know if the object was much bigger, because then the core of the object could survive, and just the envelope, the surface of the object may have been ablated in the explosion. So we don't know how big the object was to start with.
How hard was it to start this expedition, or was it not hard?
I mean, there were many failure points that one can imagine. First of all, that when I announced the expedition, we needed $1.5 million, and if we didn't get that funding, nothing would happen. So gladly, I had a Zoom call from Charles Hoskinson, and he said, "You have the money." And then, of course, getting the best professionals in the world to participate in the expedition and to design it and design the machinery, the sled. And even after they designed it, it could have not worked. There could have been something faulty in the way that it works, and it would not have collected those metallic marbles that we collected. Another failure point could have been that the meteor itself would not have produced enough spherules for us to be able to find them in just 26 runs over 14 days between June 14th to 28th. So we were using a sled of 1 meter in width, going across a distance of 10 kilometers in each run. So, it's not guaranteed that we would have found any of these spherules. If the meteor was smaller by a factor of 2, then it wouldn't have produced enough, and we wouldn't find any. So then, of course, even if we found them, bringing them back to Harvard and then not having access to this mass spectrometer would not allow us to realize that they are made of some unusual composition. So a lot of possible breaking points. And when I went to the expedition, after we found all of these spherules, we celebrated with champagne on the deck of the ship. And I asked the coordinator, "Why did you bring champagne to the boat? How did you know that we will find anything?" And he said, "I'm an optimist." So my lesson from that is it's better to be an optimist in life, because life is very often a self-fulfilling prophecy. If you tell yourself that you will not find anything, you will never search and you will never find anything. It's and that's what many of my colleagues kept telling me when I went there, and they said, "Why are you wasting your time and resources?" And I said, "I'm not asking you to do anything. I'm doing the heavy lifting. You just sit back and relax." When I came back and brought stuff, they told me, "You didn't bring anything." In fact, there was a scientific paper published in the Astrophysical Journal saying, "Oh, it's just a stone. The government measurement is off by a factor of 3. It's much slower. It's actually a stone from the solar system." And I call that the stone age of science, when everything in the sky must be stones. And then now, after we posted the scientific paper, which took us a huge amount of effort over the past couple of months to write, and analyze it. It's unprecedented. There is nothing like it in the scientific literature. Still, a few of the quote-unquote haters are trying to bring it down. And I don't understand this motivation. Everyone should be excited. We're trying to uncover some new knowledge related to an object that looked anomalous. So why would anyone have a problem with that? This is just the scientific method of going to the place, finding materials, analyzing them, writing a scientific paper, posting it, and submitting it for publication in a prestigious journal. There is nothing else that the scientific method entails. And yet there are people who call themselves scientists who are arguing for some reason that this is not science. I just cannot understand that. I wrote 1,000 scientific papers in my career, 8 books, and many of these people, those that are making negative comments, many of them are bloggers or science popularizers that didn't write a single scientific paper over the past decade, not a single one. It's just like commentators looking at a soccer match and telling the players how to pass the ball. Who gave them that authority? I mean, I'm doing the science and they're telling me what to do when they didn't write a single scientific paper over the past decade. Then you have some scientists who just don't want it to be true because for them, it's not a reflection of their past expertise. It's not stones of the type that they're familiar with, and they have an issue with that. And I say, well, discuss these issues with your therapist. That's not my problem. I'm just going out to look for the evidence and basically announcing what we find. If you have a problem with the results, it's your psychological problem.
You're absolutely right. Dean and Dustin, please allow me one more question. You found over 700 spherules, right? And you analyzed a handful of them. And since they come from the same object, do you still expect different results from the analysis? And if so, what would it be?
So, yeah, we only analyzed 10% of the spherules so far, 57 of them. And we plan to continue with the analysis. It took us 2 months to get to this point with the analysis of 57. And the reason I wanted to summarize it in a paper right now is in order to get some feedback from the community, because the paper will go out to reviewers. And then if there are good suggestions about how to modify the analysis method that we are using, we can still do it for most of the sample. So this is a good opportunity for us to receive the feedback and then proceed with most of the sample. And the point is that many of the spherules are background. They are not related to the meteor. So by analyzing more, we will get a better assessment of the background. But also, we could improve the statistics on those Belau spherules that I was talking about. They were never seen before in other places. We find them only along the meteor path, not in the background, control regions.
My question actually is, how difficult is it actually these days to publish the truth and make the truth matter?
That's an excellent question. You see, I'm relatively naive. Maybe because I worked mostly in cosmology. In cosmology, the study of the universe, it's like playing chess. If you're smart, you do the right moves and you're appreciated for that. However, in this business of rocks in the sky, it's like mud wrestling. And I don't want to get dirty by mud wrestling with some of these guys. Now, why do I say that? Because in cosmology, for example, we don't know what most of the matter in the universe is. We call it dark matter. That's 83% of the matter. And I've been working on that, for decades. And for 90 years, we've been searching for the nature of dark matter. We haven't found it. We invested billions of dollars. And I know the culture of the field. You are encouraged to suggest new solutions to the dark matter problem so that experimentalists can test them. You get a positive feedback when you suggest something of interest that people can test experimentally. So naively, I thought, there are some anomalous objects in the sky. Oumuamua was the first of one. Oumuamua back in 2017. The meteor was another one. I said, well, they look anomalous. They have properties not the same as the rocks from the solar system that we're used to. And these are the first interstellar objects. So I said, look, this might be maybe technological. It might be interesting. Why not explore that? I'm driven by curiosity. And then I get these people to say that this is heresy. Basically, that I'm violating the code of scientific research just by suggesting that. And I say, look at the dark matter research. Like for many decades, billions of dollars were invested in ideas that were not proven right, including supersymmetry that was not found in the natural parameter space by the Large Hadron Collider. And nobody says a word about it. There is a whole community of particle physicists, theorists that are working on string theory, on ideas like the multiverse or ideas like extra dimensions. And there is no experimental verification for that, no clue that this is true. It's just a theoretical construct, and it's celebrated by the mainstream of hundreds or maybe thousands of theoretical physicists. And there is not even an opportunity to test these ideas in the coming decades, in their lifetime, in their career. Nevertheless, that's accepted. So when I'm talking about anomalous objects and saying, I will go myself to the Pacific Ocean, collect the materials, study the materials, what could be more realistic than that? And why would that be heresy to the way that science is done when people are talking about things that cannot be even tested? And it may be related to the culture of people that worked on space rocks, but I think it also reflects something more fundamental about the nature of academia, where the beaten path, that is popular, is completely accepted, whereas exploration of new ideas, innovation, and things, in my case, it's not so much that, but it's just that this subject appeals to the public. So there is a huge amount of attention. There was a New York Times Magazine article just last weekend, a profile about me. They never do it on scientists, okay? And in it, they said that I'm the most well-known practicing astrophysicist. And why is that? Why is that? For two reasons. One, that I resonate with the public's interest. The public cares less about the nature of dark matter, believe me, than whether we are alone in the universe, okay? So I talk about that, and the public cares about it, so I get attention. I also get attention because my people who work on space rocks keep bullying me and saying negative things. So obviously it creates some sense of controversy, but all I'm doing is following the scientific method. I have a lot of experience in doing that. There are scientists working with me following the scientific method. And the fact that there is rejection of this approach of examining something of interest to the public using the scientific method says that something is wrong in the culture. Because why would studying self-interacting dark matter with some interactions that were never found in the laboratory, just because it may be useful to explain some data, why is that legitimate when saying that an anomalous object that is perhaps analogous to the spacecraft that we launched? Okay, we launched these things. We know that there are billions of Earth-Sun systems that preceded the solar system, that formed billions of years before the solar system. What could be more natural than to say, okay, we are sending out, objects to interstellar space. They may have done that already, and these objects may be near us. Why don't we check? We see some unusual. I didn't dream this up. The mainstream people trying to explain it admit it because they try to explain it. Already 5-6 years after it was discovered, there are still papers trying to explain it. That means that it's not trivial, okay? And this meteor also, so what do they do about the meteor? They say the data is wrong. Instead of allowing for the possibility that their model is wrong, they say the data is wrong. And then they attack me for going to that site. And then they say, no, what you found is something that is everywhere. And then so this is something really problematic because it suppresses innovation. And when young people see that, they realize, in order to get a job, I better just, dance to the tunes of those who are chasing any different idea because it bothers them. And I think this is bad for science because it means, that innovation will only happen in the private sector, where you have companies developing AI far beyond the level of development on campuses in academia. Why is that? Because academia is all, self-indulging. People are just trying to promote their ego, to get honors, awards. They don't care so much about the content but just use it as a vehicle to show off. And the fact that there are these groups of people chasing after any innovative idea and trying to bring it down, rather than saying, okay, well, let's allow for that. Let's explore it experimentally, find out if it's right or wrong. Why is there this negativity? That I think is pretty bad.
Let's talk about possible extraterrestrial life for a moment here. I heard you say that an advanced civilization might be able to produce life and maybe even a baby universe in its laboratories if they only knew how to engineer the unifications of quantum mechanics and gravity. And you said that if you could have a dialogue with extraterrestrials, your first question would be what happened before the Big Bang. It's thought processes like that keeps the world moving, I think. And these thought processes ensure that we do not get stuck in old thought patterns.
Well, the reason I brought this up is because we have a notion of God in religious texts. And, the qualities of God are to produce miracles, the things that we can't understand, to produce life, according to the story of Genesis, produce the universe, okay? And in principle, all these things can be produced by an advanced technological civilization. Mm-hmm. And it would look to us like miracles because when a cave dweller, would go to Manhattan in New York City, it would look like magic, all of the lights and the gadgets. So what we call superhuman abilities that we assign to God could actually be in reality once we encounter such gadgets far more advanced. And it's an opportunity for us to learn. And when I was on the ship, on the boat, I was jogging every morning at sunrise, just like I do on land. And in one of the mornings, someone asked me, Avi, it looks like you're running. Are you running away from something or towards something? And I said, I'm running away from some of my colleagues who have strong opinions without seeking evidence. And I'm running towards a higher intelligence in interstellar space.
Since your recent discovery, have you analyzed any other questionable artifacts from maybe UFO cases?
So we have, I'm leading the Galileo project, and we built an observatory at Harvard University, which is monitoring the sky 24/7 in the infrared, optical, radio, and audio. And we analyze the signals that we get with machine learning software. And we are looking, every time I speak with my postdocs, I ask them, did you see anything anomalous, anything unusual? Because the US government talks about it. There was a hearing a month ago at the House of Representatives about anomalous phenomena, unidentified anomalous phenomena. And there were testimonies by three people. Two of them are pilots, and one was David Grush, who argued that the US government has retrieval and reverse engineering programs of alien spacecraft. And after, he based it on conversations he had with 40 people. And my hope is that the US Congress will contact these people and see if there is anything behind it. But I'm not holding my breath for the government to disclose the information. That's why I'm doing my work as a scientist. The oceans are not classified, the sky is not classified. So we are planning to make additional copies of this observatory at Harvard. There may be 5 of them in the immediate future, within a year or so, and altogether maybe 100 or so if we get the funding. Each of these is a fraction of $1 million. So we just need the appropriate funding, and then we can make all these copies and get to the bottom of what these anomalous phenomena are, because we'll get high enough statistics of objects in the sky. But so far, we haven't seen anything unusual. That's one. Yeah.
There's just one question, because we are towards the end of this great exchange that we have had so far. I have a simple question. When are we gonna do the first meet and greet with an alien?
So I don't think that we're likely to meet a biological creature, because the travel time is very long. Using the laws of physics as we know them, the speed of light is the limit, and it takes even light thousands, tens of thousands of years to traverse the Milky Way galaxy. And the chemical rockets that we used would take a billion years to go around the galaxy. So it's a long time, and most likely it would be functioning technological gadgets that could survive such a long journey. And then it would probably they would have a brain of AI, artificial intelligence, and we could use our own AI to figure out their AI. So it will be, because they will have kinship to each other more than to us. And I think I prefer not to imagine what they might look like, those functioning devices, because all of that is based on our experience so far, and it may be very surprising. So there are some people who want to establish a committee that will decide about a protocol of how to respond to a visitor. And I don't think it's prudent, because our imagination is limited. When you go out on a date, it's better not to expect what you see in the mirror, before you leave the home, because it could be better. It could be surprising, and so we should respond to whatever we find. And then I think there should be a large population of things that are just space trash, which are not functional. just because our own probes that we sent so far, once they leave the solar system in 10,000 years, they will not be functional. Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. So there will be a lot of space trash, objects just colliding with Earth.
Yeah, I read this interesting book that was written by two great guys here in Germany, Dr. Andreas Anton and Dr. Michael Schetsche. It's called Meeting the Aliens. And in this book, they come up with the theory that it could cause very big trouble if we should ever find extraterrestrial technology, maybe on the moon or so. These are just theories. Who has the right to research, and what are we going to do with it? Of course, everybody wants it because it's technology, right? This could lead to big problems. So, and since you mentioned the idea of the AI, to me, the idea that extraterrestrial life could be maximum strange and foreign to us sounds very interesting. And these two authors that I just talked about also referring to that these intelligences could be extremely advanced artificial intelligences. They could have developed artificial systems and are connected with them. And they may have become some kind of post-biological life form. And that's a very scary and also fascinating thought. What do you think?
Yeah, so, it takes us time to learn from biology. The Wright brothers learned how to fly about 120 years ago. We've seen birds for hundreds of thousands of years before that and never were able to imitate them. We just last December were able to produce nuclear fusion, a breakthrough in the laboratory using lasers. When the sun has been doing it for 4.6 billion years, next to us. We don't have cars that heal themselves after a minor accident, although our human body, when we have a scratch, it heals. And we don't have self-replicating objects. Like, you don't have a 3D printer that can make a 3D printer when you put it in the wild, that's what biology does all the time. It's using materials in the wild for DNA to replicate itself, of flowers, of anything, of humans. So there is a lot for us to learn. And of course, the ultimate thing would be to create a self-replicating probe, something you send to space with artificial intelligence, 3D printing capabilities that can, just like a seed, it can carry information and reproduce itself or reproduce life as we want it, elsewhere. Instead of carrying, the old ideas of science fiction was to carry humans, just like Noah's Ark in the Old Testament. By the way, I discussed this in my new book that just came out, Interstellar. I call it Noah's spaceship. So you might think that you need to send all these things in such a giant spacecraft, but no, you can have a small probe that has self-replicating capabilities and can produce life as we know it out of the nutrients, out of the raw materials on the planet. And of course, when it does it, the question is, what will you get? It will not be the object that came originally. It will be something else made out of the materials on the planet. And that would be interesting to look for. And it could terraform a planet. It could change it. There is a question of whether Earth was visited, and maybe, that's what led to some of the big events that we know in the history of Earth. There were major changes in the climate, in life. It's not clear what made our atmosphere have suddenly a lot of oxygen from cyanobacteria. I mean, we know it was produced by cyanobacteria, but very rapidly over a short period of time. Why did it happen? It's not clear. And so I should also say that behind you, there is this picture of high-rises that look like an alien city. But even if Mars had such structures, within a few billion years since Mars lost its atmosphere, those structures would be completely demolished, because if you just calculate the impacts by asteroids on the moon or Mars, they don't have an atmosphere. And so you end up with roughly 20 Hiroshima atomic bombs per square kilometer in terms of the energy released over a few billion years. So any high rise, just think about it, 20 atomic explosion in every square kilometer, they would destroy any infrastructure that you might see. And that's why we see so many craters on Mars or the moon. But what might survive is underground, and the question is there anything interesting underground? And at the very least, if I ever have the fortune of sending a mission to Mars, I would like to send the probes, small drones into caves, the lava tubes that are on Mars, to search for prehistoric paintings. If Mars lost its atmosphere just at the middle of its life, about 2 billion years ago, it could have had intelligent life twice as fast as on Earth. So if it had intelligent life, at half the time that it took Earth to produce it, we should find something in those caves on the walls, and that would be interesting to check for.
Absolutely, Avi. I think we've come to an end now. It was great to talk to you again.
Besides, thank you for your time. That was awesome.
Thank you for
very
having
much.
me. And for more, you can find essays on my medium.com outlet. If you just search for Avi Loeb at medium.com. And also my new book, Interstellar, that just came out a few days ago.
Mm-hmm. Thank you. We will put a link in the description, of course. And I'm getting your new book. I will. Thank you.
Thank you.
Thank you so much.
Thanks for having me. It was a pleasure.
Have a great rest of the day.
Bye-bye.
Bye-bye.